Continuing on page 60, we did B up in the top left corner, and I need to erase some of this check so I can have some room over here for problem C. So I'm sure you copied down, I hope you did, what I've had on here in the other video. If not, you can go back and watch the video to pick it up. So, you know, there's some exceptions. There's always exceptions. Stuff that looks weird are perfectly vertical lines, are perfectly horizontal lines, are all real numbers, are no solution kind of thing. And we're going to have those when we're solving systems of equations as well. So, but you don't know when they're going to crop up. So you're going to start out just like we started out before. We're looking, remember, we're looking, look, this is the easiest way to do substitution. I can't help myself to draw these little eyeballs. Look for variable with coefficient of 1. If you have one. We've got 4 variables in these two equations. 3 of them have coefficients that are something other than 1, but we do have y by himself in this one. So this is going to be a good one that we're going to use to substitute into the equation below it once we get the y by itself. So we're going to take this guy and we're going to say, okay, y equals minus 3x plus 2. So if y equals minus 3x plus 2, I can come down to this second equation, and instead of writing y there, I can replace it with minus 3x plus 2. And that's what I'm going to do. So 6x plus 2, and instead of y, I'm going to write the minus 3x plus 2, because that's another name, another way to call y in our particular system. So what does that do for me? It gets me down to 1 variable in this equation. So it doesn't always have to be y. If x had been alone, we could have substituted in for x. But once we have just 1 variable in our single equation, we can solve for it. So we've got distribution we need to do. So 6x minus 6x plus 4 equals 4. Right? So I end up with the 6x's canceling each other out, and I get 4 equals 4. Well, that's kind of a silly place to end here, but when you get a statement that looks like this, that means this is always true. So in other words, you have an infinite number of solutions. Now remember, we can't say, I've lost this pen, come on, where'd you go? There it is. Remember, we can't say all real numbers because the only possibility for solutions are the ones that are on the lines, not all the rest of the points in the coordinate plane. So when we get a statement that's always true, like this guy, 4 is always equal to 4, we say we have infinite solutions. And that means there are an infinite number of points on our 2 lines, because the lines go forever and ever, and all of those points are a solution to our equation. So infinite solutions, and this is always true. All right, let's look at this next one. Here we've got another system of equations. I've got 3 of the 4 variables with coefficients that are not 1, but x right here is a 1, so that's who I'm going to use for my substitution. So x is going to be equal to minus 2y minus 3, and that's what I'm going to plug in for this x right here in the next equation. So 3 plus 6y equals 9, and I'm going to do the substitution of minus 2y minus 3. Distribute, minus 6y minus 9. Let me get down here where I am. Minus 6y minus 9 plus 6y equals 9. The 6y's cancel. They're opposites, they add to 0, and we're left with a statement minus 9 equals positive 9. And of course, this is never true. So this is a situation that's the exact opposite of the one we just did. This is never true. Therefore, that's what these 3 dots in the little shape of a triangle. This is kind of an interesting piece of trivia. When you see that in math, this means therefore. You know we have shortcuts for everything, symbols for everything. This is -9 equals 9 is never true. Therefore, there is no solution to this system of equations, or you could write the null set. All right, let's look at one more example on this page. I'm going to need a little space. I think I'll start up here. I have two variables that have a coefficient of 1. It doesn't matter. This is your choice of which one you start with. So I'll just say, okay, I'll solve for A. A is equal to minus B plus 15. Maybe you can try it on your own and solve for A and see if you get what I get. So I'm going to come down here and I am going to plug in for this A right here. I'm going to plug in minus B plus 15. So I'm going to set up my shell, leave the open space, and now I'm going to plug in for A minus B plus 15. Okay, didn't leave quite enough space. So when I distribute, I get A is equal to, 15 minus B. So that's minus 3B plus 45 minus 2B equals 5. So I get minus 5B equals minus 40 when I subtract 45 from both sides and when I combine my like terms. And then I divide both sides by -5 and I get B is equal to positive 8. So that's my first step, and I think I know now my ordered pair is going to have an 8 as the B value or the Y value, and now I need to go find what the other value is going to be. So I'm going to pick this short little equation to plug in for B. So I get A plus 8 equals 15, so A has to equal 7. So this is what I think my ordered pair is, and now I'm going to do one last thing to prove it. I'm going to plug both of them into this guy right here and make a true statement, hopefully. So 3 times 7 minus 2 times 8, is that really going to be equal to 5 when I do this arithmetic? So 21 minus 16 equals 5, and yes, indeed, 5 equals 5. So there's no doubt in my mind that we have done that anything but perfecto. Thanks for watching.